Hello and welcome to this video about large signal diode impedance. I made a mistake in my last video about the time varying impedances for capacitors and inductors. I should have really based them on 3-point stencils and not on 5-point stencils, because the waveforms can get too spiky to use the longer point stencils to approximate them. So here is the inductor impedance based on the 3-point stencil for differentiation, and the capacitance impedance based on the trapezoidal rule. And here are the corresponding admittances, which are the inverses of the impedances, and these are the values that we'll be inserting into the circuit matrix. And here is even another inductor admittance matrix. Notice that the area over an entire cycle is equal to 0, and this is reflected in the ones in the top row. And this is the input voltage waveform for all of the circuits that I'll be simulating. It is a standard sine function. And using these new matrices, the voltage across a diode in the bridge rectifier circuit can be calculated, which is shown below. And the voltage across the load here, which has a bit of oscillation due to the numerical method and not due to the circuit, so it isn't even quite perfect yet. And here is the waveform across a load resistance in a half-wave rectifier with an inductor in series. There is a slight bit of squelching of the waveform, which is in agreement with theory. And here is the voltage waveform across the diode. It has a lot of oscillation caused by the numerical method, not being able to properly work with the inductor model. And here is the voltage waveform across the inductor, which also has a lot of oscillation. And here is the voltage waveform across the inductor and diode in series. Notice that their oscillations cancel each other out, so that the other parts of the circuit are not affected. So if we double the inductance in the same circuit, this is the voltage waveform across the load resistor, and it looks even more squelched, like it would in theory. And here is the voltage waveform across the diode, which is oscillating even worse than for the last circuit, and the voltage is in a wrong direction in some places along it, which shouldn't happen. And here is the corresponding voltage waveform across the inductor, which is oscillating equally badly. But the good news is that the voltage across both of them has none of these oscillations, since they seem to have cancelled out. And when we place a capacitor in parallel with the load resistor and measure the circuit for L equals 50 henries, then we get this waveform across the load resistor, which is fairly well behaved. And this is the voltage across the diode, which is even more badly behaved. And here is the voltage across the diode and inductor together, which seems to cancel out the bad oscillations, and pretty much nearly completely. So I hope that this video has been helpful for you in your quest to make circuit simulators that can simulate circuits containing inductors, capacitors and diodes all mixed together. I will be trying to make some other sorts of diode impedances based on different functions, like multiple sinusoids, like cosine and sine functions, and even polynomial impedances.